Hi friends, welcome back. Today we're going to code a project together that processes a list of documents, use LLMs to extract relationship between the concepts in each document, and export the nodes and relationships to build a knowledge graph. We're going to extract the entities from the documentation using LLM. You can refer to the entities like terminology, for example, indexing flow, data, basic type, struct type, and all that, and extract the relationship between entities. And in addition, generate a relationship that where each entity is mentioned on which document. For example, the basics markdown mentions CocoIndex supports incremental processing. It informs the following graph. There are two entities or terminology, CocoIndex and incremental processing. There are two kinds of relationship. The basics mentions CocoIndex, and it also mentions incremental processing. And second, CocoIndex has a relationship with incremental processing. The relationship is labeled by supports. CocoIndex supports incremental processing. And once we're done with AI-assisted data transformation, we're going to build knowledge graph in Neo4j. As you can see, the pink nodes are different files, like the basics, flow definition, and around the pink nodes is mentions a few entities or terminology, for example, type, rows, and they have relationship to each other. All right, let's get started. Before getting started, I want to thank the community. We officially crossed 1K stars earlier this week. Huge thanks to everyone who started, forked, contributed, or shared love for CocoIndex. CocoIndex is a real-time data framework for AI. The problem it tries to solve is to make it easy to prepare fresh data for AI, either creating embeddings, build knowledge graphs, or perform other data transformations, and take real-time data pipeline beyond traditional SQL. We are constantly improving, and more features and examples are coming soon. If you love this video, please give us a star at our GitHub repo to help us grow. CocoIndex makes it easy to build real-time knowledge graphs. We officially supports property graph targets. Property graph is a widely adopted model for knowledge graphs where both nodes and relationships can have properties. Neo4j provides these graph database concepts with a good introduction to basic concepts of property graphs. I recommend you to read it if you are not familiar with the basics. The following concepts are particularly relevant in today's tutorial. Nodes are used to represent entities of a domain. Property graph target, there is something called the node labels. It is more like to defining the type of a node. For example, this node can be a person, actor, and you can define properties on the graph. For example, name, born, and all that. Another important concept is relationship. Relationship describes a connection between two nodes. For example, earlier I mentioned CocoIndex supports incremental indexing. It defines a relationship between two entity nodes, CocoIndex and incremental indexing. There is something called relationship type. Relationship must have exactly one relationship type. For example, this actor acted in a movie, and acted in is a relationship. And lastly, the properties. It's actually pretty simple. It's just key value pairs associated with nodes and relationships. Let's get started with the project, and I'll walk you through all the concepts with examples. We need some basic setup for this project, which takes a few minutes. First, we need to install Postgres. Index uses PostgreSQL internally for incremental processing. We also need to install Neo4j, which is a graph database. If you don't have one, you can follow this tutorial here. Lastly, we need an OpenAI API key. You can also use Ollama if you want to run everything on-premise. Let's make a project folder. PyProject.toml. Okay. Here we'll add some basic description and dependencies that we will need for this project. Create our main file. We're going to create a data flow to transform docs to knowledge graph. And I'm going to import the files. To make this project more explainable, I'm going to spin up CocoInsight. It's a data observability tool made for CocoIndex, so we can inspect the effects step by step by observing the data. Okay, let's make sure to import the dependencies and also create a main. Let's make a .env file. Paste the database URL for Postgres and your OpenAI API key. Let's install the dependencies. Set up the flow. Then let's do update. So as you can see, we processed the 7 source rows. I'm gonna spin up the CocoInsight. So this is a view of CocoInsight. The right side is a visualization of the data flow. Right now it's pretty simple. We ingested a list of documents from a local file. The CocoIndex load from file generates a K table of documents. It generates 2 columns, file name and content. You can easily view the data on the left side. As you can see, in the core folder, we have a list of files, CLI, basics, data types. Each of them has a corresponding content. For example, this one, you can scroll down to see the original Markdown files. Cool. Next, I would like to add some summary for each document. I'm going to add a document collector. The document node collects documents. For example, the basics.markdown is a document. And then we're going to process each document. Let's define a data class called document summary. This data class describes a summary of a document, so a document should have a title and a summary. And we're going to instruct the LLM to perform this summarization for us on each document. We're going to take the content of each document and perform transformation on the document by calling extract by LLM and give it the data class as an output type for the document summary. And then we are going to collect the file name, the title field, and the summary field from the summary. Let's take a look at the effect in CocoInsight. So as you can see here, we added one more step, which is to process each document. For each document, we're going to call extract by LLM, and the output give us a struct. It contains title and summary. This is based on the data class we defined earlier. And then let's inspect the data. So as you can see, for each of the file name, we added a summary column. For each of them, you have a title, which is the title of the document, and we instructed the LLMs to generate a summary for each of the document. And you can just click on Showing More to see the full summary below. And now let's deal with the relationships. Let's add the relationship collector. The entity relationship collects relationship. For example, CocoIndex supports incremental processing, indicates a relationship between CocoIndex and incremental processing. Let's define a data class for relationships. This is a classic triple definition. In this data class, we define a subject. The subject represents the entity the statement is about. For example, CocoIndex. It defines a predicate. The predicate defines the type of relationship or property connecting the subject and object. For example, surpass. And an object. The object represents the entity value that the subject is related to via the predicate. For example, incremental processing. Because we are going to surface this data class to the LLM to help with better structured extraction, we recommend you to write a detailed docstring to describe what is this data class about. Now let's extract the relationship by LLMs. So for each document, with the content of each document, we are going to transform it by calling the LLM extraction. We will pass it the relationship data class we defined earlier and a custom prompt. In this example, we don't have a set of predefined entities, which you can, and we will just instruct the LLMs to extract the entities as part of the relationship. As you can see in the relationship data class, we instructed the LLMs to extract subject, predicate, and object, and here subject and object are going to be the entities. Just to better understand what we have just done, for each document, we added one more transformation called extract by LLMs, then extracts relationship. The output of the relationships is a L table, as there will be multiple relationships as a list when you extract from a file. For example, CocoIndex supports incremental indexing. CocoIndex is DataFlow driven programming is another relationship. Each relationship contains three fields, the subject, predicate, and object. Just to make it easier to understand, let's take a look at the data. For example, let's take a look at the basics. As you can see, it has extracted 11 rows. I'm gonna take a look at what is 11 rows for. So as you can see, index is for data retrieval. CocoIndex helps build. An object is indices. Indexing flow extracts data. As you can see, each row here indicates a relationship that was extracted from the document. We can take a look at some more examples. For example, maybe data types can be interesting. Data types has 19 rows. So basically, there are 19 relationships created from this document. And we can see, okay, CocoIndex is processed by data. Data is a subject. Predicate is determined at row definition in, and object is type. For each relationship, let's collect it. I'm just gonna call entity relationship.collect with the ID, and you can just call a CocoIndex, a UUID, and a subject, object, and the predicate. Just to check in our Coco Insight, and we just added one more collector to collect the data. So basically, after we generated the L table of relationship, for each of the relationship, we added a collector, then we collected ID, subject, object, and the predicate field. Now let's collect the document mention. So basically, like in basics, we are mentioning the CocoIndex, incremental indexing. So this information should be fairly easy. We don't need any additional LLM instruction. All the information we need should be already presented. Within this scope, we already have access to each of the relationship. And each of the relationship have a subject and an object, and the relationship is within the scope of a document. So you already have the information of, okay, this document have mentioned this subject, and we just need to collect it. So I'm going to do entity mention.collect. For this entity mention, we're going to collect from the subject of a relationship, and we're also going to collect the file name. And in addition, let's also collect it from the object. For example, there's a document that mentions CocoIndex, supports incremental indexing, then both CocoIndex and incremental indexing gets collected as part of the entity mention. And just going back to the Coco Insight to see what has happened. As you can see here, for each of the relationship, we have added two more collector. One is to collect from the subject. The other one is trying to collect from object. And both of them collects entity and file name. You can also inspect this by click on this little icon here. As you can see, this collector collects from the subject from a relationship to the entity, and this collector collects from object of a relationship to the entity. Cool, I think now we have all the information we need from the data transformation, all the way from importing a file, transforming the data, collecting the data. Before we export them to Neo4j, we can do like more sanity checks on to inspect the data. For example, does all the relationships looks right? Are we missing anything and all that? Now we can just export the data to Neo4j. One of the nicest thing I like about CocoIndex is that users don't have to worry about data operations like creation, update, or deletion. So it is more about defining mapping and transformation. For example, I have a set of source data. It went through a set of transformation, and how do I map them to the target store? And in this case, it's Neo4j. And let's take a look. It's actually pretty easy. We have very detailed documentation about how mapping to Neo4j works. Essentially, it's around nodes and relationships. So all nodes for Neo4j needs two things. First is a label. The label is like type of the node, for example, document, entity. And second is primary key field. That's a field that uniquely identifies the node. For example, the file name for the document nodes. CocoIndex uses the primary key field to match the nodes and deduplicate them. If you have multiple nodes with the same primary key, CocoIndex keeps only one of them. For example, CocoIndex supports incremental processing, and CocoIndex belongs to the EDO framework. After deduplicate by the primary key, it becomes an entity CocoIndex, supports incremental processing, and belongs to EDO framework. Now let's map to Neo4j. Now let's export the nodes to Neo4j. We're going to need the connection spec, and let's first export the document nodes. This exports Neo4j nodes with label document from the document node collector. The label, as you remember, label is a node type here. It declares Neo4j node with a label document. It specifies file name as a primary key field. It carries all the fields from document node collector to Neo4j nodes with label document. This is a fairly straightforward export because we have a dedicated node collector just for this kind of a node label. I'm going to run one update and going to connect to Neo4j and see what's going on. I'm going to run CocoIndex setup. As you can see, it's going to create the Neo4j node. And then CocoIndex update. So let's open the Neo4j browser. As we can see, we have 7 nodes with the label document. We're just going to click on it, and we can see all of the nodes here, each node corresponding to a document. Now let's collect the relationships. We don't have explicit collector for entity nodes. They are part of the entity relationship collector, and fields are collected during the relationship extraction. Let's begin with declaring a node label. This defines a node label entity with primary key fields value. And then let's export the relationships. The CocoIndex storage.relationships declares how to map relationship in Neo4j. In a relationship, there's a source node and a target node, and a relationship connecting the source and target. Note that different relationships may share the same source and target nodes. Note from fields takes the fields from the entity relationship collector and creates entity nodes. Let's rerun the setup and updater. This new operation mapped to Neo4j is added. And let's switch to the Neo4j browser. As we can see, we just added the entity nodes here. This query is going to match all the entities and the relationships too. And you can click on it. For example, here, the flow is discussed in flow definition. Let's look at another example. There is a relationship between struct and fields, and it is from the struct are part of fields. We're almost there. Let's also map the entity dimension to the Neo4j relationship. Since we're adding new nodes, let's rerun the CocoIndex setup and update. CocoIndex setup. Okay, we're going to add new relationship which has a type mention. Yes. And update. Let's bring up Coco Insight. And just to see, we have mapped from the collector to the new kind of Neo4j relationship. Let's go to Neo4j. I'm going to select all the relationships. Now we're seeing all the relationships. The pink nodes are the high-level files. Each file mentions a list of entities, and the entities has relationship to each other that is extracted by LLMs. That's about it for this project. I hope it is helpful and you've had some fun. If you have made it this far, please support us by dropping a star at CocoIndex GitHub. We are making huge progress each day, and stay tuned for more updates.